Assalamualaikum, my name is Syed Muhammad SUDIRMAN by AFFANDI. Matric number AE230002. Today I will show the simulation for test 1, test to find induction motor. Okay. We set the squirrel cage pressure model to 30. Okay. So this is our circuit. And then run. Okay. So this is our result. That's all. Thank you.
Assalamualaikum warahmatullahi taala wabarakatuh. Nama saya NAZRIN AMIRUL NAIM bin AZHAR. Today I will show you about task 3 simulation. So no load power, and then this is our simulation. This is our circuit. You can see in this MATLAB. So from my group, I am from group 10. So group 10 is used for preset 13. Then I will apply and okay. So I will run the simulation, and we can see the value of V phase, I phase, and PSC. So I will run. After compiling this after we run, MATLAB will compiling your circuit. So as we can see, this is our value for from simulation, which is V phase. We know we use 3 phase, so we can get 3 V phase, 3 I phase. So the value is shown to you. So that's all from me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad YAMIN bin KHALILI, and my matrix number is CE220015. Now I want to present for the test 2, which is the title is block rotor test of 3-phase induction motor. So for this simulation, we run for the 3-phase. So we have a 3-phase here, and then for this simulation we must run 5 volt 1 to 5, and then we change 4 to 1, and then we must click for the synchronous machine, and we from group 10 we must use preset 13, and then we run the simulation. So we can look here for the V, and then this for the I, and then this for the PSC. So now we change to second vote with 2 vote. Now we run. Now we can see for the value of V, value for I, and then value for PSC. And then now we change to 3. Now you can see the value if we change to 3 for the V, I, and PSC. Now we change to 4 vote. Now we run simulation. For the result, for the 4 vote, for the V, for the I, and for the PSC. And for the last one is 5 vote. So we change to 5 and we run the simulation. So now what we get for the V, for the I, and then for the PSC. So that's all from me, and thank you.
Hi, my name is Sanjeev Naidu, son of SEENIVASAN, number metric CE230019. So I'm here to explain about test 4 of three-phase induction motor and the torque speed characteristic. So the first of all, let me talk about the top speed characteristic of a three-phase induction motor is a fundamental curve that shows how electromagnetic torque varies with rotor speed. It's essential for understanding motor performance in various load conditions. So the key parameters is T is equal to torque and S is equal to slip. So the formula will be slip S minus slip rotor equals to slip, and synchronous speed is equal to ns. So the rotor speed is equal to nr. So the supply frequency is f as usual, number of poles sp, and ns is equal to rpm in rpm. So let me explain about the simulation that I did earlier in the Simulink. So this will be the three-phase source. So I've used a three-phase source, and this will be the synchronous machine. This is actually the synchronous for the squirrel cage. It's also called as squirrel cage. So the squirrel cage preset module, as we can set to 5.4 HP is equal to 4 kilohertz and 400 watt and 500 hertz, 50 hertz and 1430 RPM. So the rotor type I changed to squirrel cage. So if we change this, and the mechanical input is speed, and the reference frame is stationary. So we press apply and OK. And we add this, and this shows the display our speed in RPM. So we press run. So as you can see, the once it start running, and you can see the RPM has changed to 1528 RPM. So this due to because this is due because of we use the gain. So the gain is equal to 60 per 2 pi NR rotor speed. So press apply and okay. So the step. So we also can measure the graph. As you can see, the formula I've used as this T is equal to Ks is equal to K is actually equal to constant depending in supply, and R2 is equal to rotor resistance, and X2 is equal to rotor resistance. So this is the formula I've used for the calculating the graph. So if I double click on the graph, as you can see, the graph is over here because earlier on I've set the sample and hold to 70 initial condition. So this is optional, this sample and hold of having. So if I'm not having the sample and hold, let's say I delete this. So if I run again, so as you can see, the RPM over here changed to 1528 as same as usual. So as you can see, the graph for scope 1 is straight, and for the other one it's over 1500 RPM, and for the rotor speed is over 1500 RPM, and for the electromagnetic torque, as you can see, this is the electromagnetic torque for the scope. For the previous graph, I'm not sure. But for the initial electromagnetic torque graph will be over like this. So that's all for me. Thank you very much.